So for this question, I see 1 plus cosine n over e to the n. The first thing I'm thinking of is this. What does the graph of cosine n or cosine x look like? It's bounded. That's the biggie. It looks like this. Without putting in my numbers, I guess we could put them in. This would be 2 pi. This would be at pi. But the y values never get bigger than 1, and they never get lower than -1. So this part of the problem, this number is always between -1 and 1. So worst case scenario, I might look at this and say, the biggest this number could be would be 1 plus 1 over e to the n, which is 2 over e to the n. And let me write term for term. That's what I'm going to get. And so I would compare this one to, compare it to this series. N goes from 1 to infinity of 2 over e to the n. Which, by the way, does what? Converge or diverge? How do you know? Here's a hint. Let's factor the 2 out. Here's another hint. This is the same as 1 over e to the n, like that. Does this converge or diverge? Converges. Why? Geometric. That's a geometric series. R is 1 over e. That converges. So my comparison, I would compare to this guy that I know converges. Converges geometric. R equals 1 over e, which is between -1 and 1. I just shouldn't say less than 1, but it's between. It fits the area where R needs to be to converge. So this converges, and since term for term, let's see, if the numerator is smaller, that the denominator is the same, that means the fraction's smaller. And so term for term, this fits, this converges with the comparison test. Okay, I didn't intend to work that one completely out, but it just sort of happened that way.